Yeah, good afternoon. So the remaining part of the unit number 2, so the addition to concrete. So earlier we have seen the part of unit number 1, that is the admixture. So various types of admixtures, then the effect of that admixtures on the properties of the fresh concrete that we have seen. So there are various properties of fresh concrete are there. So this workability of the concrete, then your strength of the concrete, durability of the concrete. So if we add the admixtures into the concrete, then the properties of concrete will be changed, and that properties of concrete, the main properties of concrete are the workability, strength and durability. So other many more properties are there. So the effect of effect of the admixtures, whatever we can add, that effect we can see if the admixture adding into the concrete. So the admixture part is over. Now the next part of the unit number 2 is the addition to concrete. So the generally we are adding some other materials also into the concrete. So the other materials are fly ash is there, then silica flume is there, then granular other materials are there. So that material we are adding, or that material we are adding and replacing to the cement, replacing to the coarse aggregates in somewhat percentage. So what will happen? So generally we are here we are talking about the concrete. So the concrete is the main mixture of the cement, sand, aggregates like and water. But so this is the normal convention, addition of cement, sand, aggregate. But with this we can add many more materials. That materials can improve the quality of the concrete. That materials can maintain the workability of concrete. That materials we can add, that materials uh, increase the strength of the concrete, increase the durability of concrete. So we are adding some other materials into the concrete also. That what are these materials and what is the specifications, what is the chemical composition, and what is the effect on the concrete, that we will see here. So the next point of this unit number 2 is the addition to concrete. So what we can add, that we will see here. So if you see the first addition, the material we can add into the concrete, that is the fly ash. So as we all are familiar with the fly ash, generally the fly ash is powdered material which we can add into the concrete, and we are replacing to the cement also. What we are talking. So the fly ash is a material, powdered material, which we are replacing to the cement in somewhat percentage to achieve the higher strength, or to minimize the cost of the cement. So we will see the here we can see here. So fly ash is finally divided into the resulting from the combustion of powdered coal. How the fly ash is generated? So the fly ash is a combustion of powdered coal and transported by the flue gases and collected by electrostatic static precipitator. So as I told, so fly ash is a powder. So that powder we can add into the concrete for what purpose? To minimize the cost of the cement and to increase the strength also, to maintain the durability also. And this is fly ash is the waste material, so we can use into the concrete. So we can reduce the cost of construction by adding fly ash or replacing to the cement in somewhat percentage. Are you getting? So then, so United Kingdom, UK is a one of the country in the world which is referred as a pulverized fuel ash. The UK is one of the country is pulverizing the fuel ash. This fuel ash, that fly ash is a most widely used pozzolanic material all over the world. So nowadays, so as have you seen or have you listened or learned the PPC cement, pozzolanic Portland cement? So that pozzolanic Portland cement is nothing but what? So the pozzolanic Portland cement, that is the here pozzolanic material, we can say this pozzolanic material, it means this fly ash we are adding into the concrete for the replacement of the cement ला replacement करण्यासाठी आपण काय करतोय, fly ash use करतोय, and that fly ash is a material, pozzolanic material. So overall world we can use, nowadays we are using, so as I am talking about the PPC cement, pozzolanic Portland cement, are you getting? So that PPC cement is a pozzolanic Portland cement, that is a cement of cement made up of fly ash. So two types of cement generally we are using, that Portland pozzolanic cement and pozzolanic ordinary Portland cement, and pozzolanic Portland cement. So this pozzolanic Portland cement is nothing but the we can use the fly ash into that cements, and we can reduce the cost of construction by replacing for the cement. So cement ला replace केल्यामुळे आपण काय होते, generally cost of construction आपली काय होते, reduce होते. So that if you see PPC cement, if you think about the PPC cement, pozzolanic Portland cement, if you think about that, so the cost of that cement is also less in the market. The PPC cement is available, that PPC cement, cost of PPC cement is also less. Why? Because we are adding fly ash into that, and the percentage of fly ash we are adding at 25 to 30%. So 25 to 30% fly ash we are adding it, so that we can minimize the content of the cement in somewhat percentage. So we will get we will easy to get the less cost cement. So that yeah, our fly ash is a major pozzolanic material which we are adding into the concrete. So then again, fly ash was the first used in the large scale in the construction of the you can see the Agri Horse Dam. So this dam is constructed in America, and for this dam the fly ash is used in first time in the America. So as I told, so in UK is one of the country which is referring that pulverized fuel ash, and that fly ash is widely we can use nowadays into the adding into the cement. So that PPC cement is made up of this fly ash. Okay, so as again we are here, so in the America first time this horse dam is constructed in America, and there first time this fly ash was used for this construction for this particular dam. So the approximate cost or approximate amount of 30% by weight of cement is replaced. So 30% we can replace the cement by the fly ash. So are you thinking? So if you think about one bag of cement nowadays, ordinary Portland cement, so how much cost of the one bag of cement? So about almost 370 to 390 rupees per bag cost is there nowadays. So if we use fly ash based cement, so the cost we can, so 30% we can replace to the cement by fly ash. So are you thinking about the how much cost will be reduced by this fly ash? So the 30% we can reduce the cost by the cement. So this is so that we are using nowadays PPC cement, that is a fly ash based cement. So So this first time this horse dam is constructed in America. After that, it was used in Cairn and Ferry Dam. So Cairn and Ferry Dam also used these two dams also used. Then in India, fly ash was used in a Rehand dam construction, replacing cement up to the 15%. So this Rehand dam is constructed in India, and for this dam, so in India we have used a 50% of fly ash replaced to the cement. So in this way, we can use this fly ash for as an addition to the concrete for the replacement of the cement. Are you getting? For the replacement of cement, so up 15 to 30% we are using fly ash as a replacement. So if you can think about the cost of the construction also, how much cost of construction maybe reduces. So generally, if you see this ASTM, American Society of Testing Material, ASTM, American Society of Testing Material. So that ASTM has classified fly ash into two categories. ASTM, American Society of Testing Material, has classified the fly ash into two categories. So that categories are class F and class C. So what is nothing but the class F, and what is nothing but the class C. So if we see here, the fly ash in the class F, so there are these are the two classified as per the ASTM. So the fly ash is normally produced by burning this anthracite or bituminous coal, usually has less than 5% CO. Calcium oxide is having a 5%, less than 5%. And so and this class 5 fly ash has a pozzolanic properties only. So pozzolanic properties, so the pozzolanic admixtures also we are adding into the concrete, so that also part of this particular fly ash also. So fly ash is having two classes. So class F indicate this fly ash is produced by burning the bituminous coal, and that usually less than the 5% of calcium oxide, and that class F is nothing but the fly ash has a pozzolanic property. So then class C, what is class C? So the fly ash normally produced by burning lignite or sub-bituminous coal. So how fly ash is produced? The fly ash is produced by burning the lignite or a sub-bituminous coal. So this class C fly ash may have a calcium oxide content in excess of 10%. See, in class C, the calcium oxide content is having a more than 10%, and in the class F, it is a less than 5%. So that more than 10% calcium oxide content is there in the class C. So in addition to these pozzolanic properties, so there is a pozzolanic properties is there. So this addition to this pozzolanic properties, class C fly ash also possesses cementitious properties. So generally fly ash having pozzolanic properties are there, but this class C fly ash is there. It having a centimetres properties also there, and this fly ash, when we tested into the accordance with the method of test specified in IS 1727/1963, so we can test the class. So as you have tested the cement, so there are many properties of cement you have tested. So we can test the consistency of cement, we can calculate the specific gravity or other initial setting time, final setting time. So likewise we can test the fly ash also. Why? Because fly ash we are replacing to the cement. So cement is replaced by the fly ash. So some of the same properties we want. Are you getting? सिमेंट जसं आहे सिमेंटला जर आपण ऍज अ बाइंडिंग मटेरियल म्हणून जर रिप्लेस करत असेल तर आपल्याला फ्लाय ऍश सुद्धा त्याच प्रॉपर्टीज फ्लाय ऍशच्या असायला पाहिजे टेस्ट वापरतोय म्हटल्यानंतर. सो दॅट प्रॉपर्टीज अगेन टेस्टेड ऍज पर दिस IS 1727/1967. So this IS code is a very important for the any competitive examination also. So 1727/1967 is this IS code we can use for the testing of the this particular fly ash. Okay, so these are the two classifications of the fly ash, so as per the American Society of the Testing Material. So effect of fly ash on fresh concrete. What are the effect of fly ash on the fresh concrete? So the fresh concrete, generally, as I told, the concrete is a mixture of cement, sand, aggregate, and water. But we are adding some other admixtures or other materials to minimize the cost of concrete and increase the workability, increase the strength, increase the durability purpose. So, but if we add these other materials, fly ash we are adding, silica flume we are adding, other admixtures we are adding into the concrete. So if we add these materials, some of the effects on the concretes are we can observe. So if you see here the effect of fly ash on the fresh concrete. So if we add the fly ash into the concrete, what the effect we can see? So that we will see here. So if you see, if the good fly ash we can add into the concrete, so the fly ash having a high fineness. So fineness test we are conducting on this cement also. So the fineness having a high fineness is having for the fly ash also, and low carbon content. So carbon content into the fly ash is low. So the highly reactive form only a small fraction of the total fly ash collected. So as we know, the hydration process is takes place if we add the cement and water. If we mix, hydration process is take place. So similarly, if we add the fly ash into the concrete, and if the water is if the water is come with contact to the fly ash, so there may be a reactions also there. So that reactive forms, but as compared to cement, the reaction is very slow. There is a small fraction of total fly ash is collected. Then that this fly ash has collected in a chambers first and second are generally very coarse, non-spiral particle, showing large ignition loss. So this fly ash is collected in the chamber first and second chamber, and generally this is a very coarse or non-spherical particles are showing the igneous loss or ignition loss. So they can be called coal ash rather than the fly ash. So we can call as instead of fly ash, we can call as a coal ash also. So such fly ash or coal ash is not suitable for use of pozzolans, and they do not reduce the water demand. See, the water demand is not reduced by the fly ash. So fly ash is a pozzolanic material, but even though it is a pozzolanic material, they do not reduce the water demand. So the use of right quantity of fly ash result in reactions or result in the reduction of water demand for a desired slump. So if we have to maintain the slump by adding the fly ash, so the appropriate amount of fly ash we have to add into the concrete Why? To reduce the water demand and we will get the desired or required slump. जसं की आपण काय ऍडमिक्सचर वापरल्यानंतर आपण स्लम मेंटेन करू शकतो, प्लास्टिसायझर असेल किंवा अदर काही ऍडमिक्सचर्स असतील. सो वी कॅन maintain the slum, but this fly ash is not reducing the water demand. So if the water demand is not reduced, then how we will get the required slum? So the desired slum is, if we want, then the water demand is we have to maintain. So the effect of fly ash on fresh concrete, so you can learn in this particular slide, is the water is not reduced, water demand is not reduced if we add the fly ash on the into the concrete. But for why? Because we have to maintain the slum also. So slum is nothing but again properties of fresh concrete. Workability is under this properties of fresh concrete. So then next effect of fly ash on the hardened concrete. Fresh concrete is there, then hardened concrete. So fly ash again we can use into the concrete to contribute to the strength of the concrete due to its pozzolanic reactivity. So the pozzolanic for the pozzolanic reactivity, so the strength of the concrete is contributed. The fly ash is contributing on the strength of concrete also. So the pozzolanic reactions proceed slowly. The pozzolanic reactions proceed slowly, and the initial strength of fly ash concrete tends to be lower than that of the concrete without fly ash. Are you getting? So the initial strength of the fly ash concrete tends to be lower than that of concrete without fly ash. So if we talk about the initial strength of the concrete, so the pozzolanic reactions proceed slowly. So the initial strength of the fly ash concrete tends to be lower than that of the concrete without fly ash. And due to continued pozzolanic reactivity, the concrete develops the greater strength at a large age. See, the pozzolanic reactivity happens if we add the fly ash into the concrete, then the concrete develops the greater strength at large age. Means इनिशियल एज मध्ये आपल्याला फ्लाय ॲशनं स्ट्रेंथ मिळत नाही. ती स्ट्रेंथ इफ लार्ज डेज, मोर डेज कॉन्क्रीट और सॉरी लेटर डेज, नॉट लार्ज डेज, लेटर डेज एज, इट मीन्स 28 दिवसाला जर मिळणारी स्ट्रेंथ असेल ती स्ट्रेंथ आपल्याला मे बी 40 दिवसाला मिळत असेल, बट इट विल बी दी ग्रेटर. म्हणजेच आपण जरी तुम्हाला डिटेल जरी साइटचा एक्सपिरियन्स नसला तरी सुद्धा तुम्हाला हे लक्षात असलं पाहिजे की फ्लाय ॲश वापरल्यानंतर आपल्याला जी काही स्ट्रेंथ आहे ती रेग्युलर सिमेंट वापरलं, रेग्युलर म्हणजे ऑर्डिनरी पोर्टलँड सिमेंट वापरल्यानंतर आपल्याला जी 7 दिवसाला स्ट्रेंथ मिळते ती स्ट्रेंथ त्याच ग्रेडचं जर कॉन्क्रीट असेल आणि फ्लाय ॲश वापरले असेल तर ती इट मे बी यू विल गेट 10 days or 15 days if we compare about the 7 days of ordinary Portland. म्हणजे फ्लाय ॲश वापरल्यानंतर तुम्हाला रिएक्शन जी होणार आहे ती स्लोली होते. हीट ऑफ हायड्रेशन तुम्ही ऐकलंय तर जी काय सिमेंट आणि वॉटरची जी रिएक्शन होऊन जी काय हीट हायड्रेशन प्रोसेस होते तीच प्रोसेस ज्यावेळी फ्लाय ॲश ऍड केल्यानंतर केली जाते त्यावेळी ती स्लोली होत असते. सो दी स्लोली this process, hydration process is going slowly. So what happened? The strength of concrete we will get after more age of the concrete. Generally 28 दिवसाच्या क्युरिंग पिरियड मध्ये आपल्याला 100% स्ट्रेंथ अचीव झाली पाहिजे. But sometimes what happen, if we add the fly ash, what happen, that strength we will get later age, म्हणजे खूप त्याच्यापेक्षा जास्त दिवसांनी मिळू शकते. And that exceeds the that exceeds of the concrete without fly ash. So the pozzolanic reactions also contribute to making the texture of the concrete dense and resulting in decrease of water permeability and gas permeability. So the pozzolanic reactions also contribute to making the texture of concrete and the resulting the decrease of water permeability and gas permeability also. So this is the effect of fly ash on hardened concrete. So now durability of concrete. So the durability of concrete is one of the again properties of the fresh concrete, which is depends on the how you have mixed the proportion. So you can add the cement, sand, aggregate, and now we are talking about the fly ash. So fly ash if we add, so how the durability of concrete will change. So if you see the sufficiently curved concrete containing good quality of fly ash, and it shows the dense structure which offers high resistivity to infiltration of the deleterious substance. See, so we are talking about the durability of concrete if we add the fly ash into the concrete. So the concrete containing good quality of fly ash, and it shows the dense structure which offers high resistance to the infiltration and of the deleterious substances. So the point for consideration in that particular pozzolanic reactivity is to reduce the calcium hydroxide content. So if we add the fly ash into the concrete, so we can for the pozzolanic reactivity we can reduce the calcium hydroxide content, which results into the reduction of the passivity to the steel reinforcement, and at the same time the additional secondary cementitious material form and makes the paste structure dense. See, if we add the fly ash into concrete, the pozzolanic reactivity reduces the calcium hydroxide, and that resulting the reduction of the passivity to the steel reinforcement, and at the same time the additional secondary cementitious materials formed the paste structure dense, and they gives more resistance to corrosion of the steel. So if we add the fly ash, so the reactions, pozzolanic reactivity reduces the calcium hydroxide. So if the calcium hydroxide we can reduce from the pozzolanic reactivity, so we will that particular concrete will resist more resistance to the corrosion of the steel, because steel is inside into the concrete. But sometime what will happen if the concrete surface is contact with the water, then that water is seepages from the concrete area up to the steel, and steel will get corroded. But such fly ash based concrete, if we mix then we can that fly ash is giving more resistance to the corrosion of the reinforcement. So the durability will increase. Okay, so this is about fly ash. Okay, so next addition to the concrete is the silica flume. So as we discuss about the fly ash, we can add the fly ash into the concrete, and how fly ash is manufactured, how we can add into the concrete, how much percentage we can add into the concrete fly ash, then various types of or classifications of the fly ash we can see. We have seen the class F and class C. After that, some of the effects of fly ash on the concrete, that also we have learned. So the next addition material is the silica flume. So the silica flume is also referred as a microsilica or a condensed silica flume. The silica flume is also referred as a microsilica or a condensed silica flume is another material that is used as an artificial pozzolanic admixture. So we can add as a artificial pozzolanic admixture that as a another material after the fly ash, that is the silica flume. And the product of this silica flume, whatever product prepared, it means whatever concrete prepared by adding the silica flume, that is the reduction of high purity quartz. So, and with coal in electric arc furnace in the a manufacture of silicon or ferrosilicon alloy. So generally this silica flume is prepared, or that product is getting or a reduction of the purity quartz with coal. So how it manufactured? So we can manufacture with this quartz with the coal in an electric arc furnace in the manufacturing of the silicon or a ferrosilicon alloy. The silica flume is rises and as an oxidized vapor. Silica flume rises as an oxidized vapor, so it will cool and condense, and it collected on the both cloth bags. So cloth bags are there. So in the cloth bags we can collect this particular silica flumes. So it is again further processed to remove the impurities and control particle size. So the control the particle size. So silica flume is processed to remove the impurities into the present. So again we can control the particle size also. So then silica flume has also specific surface area about the 20,000 meter square per kg. Silica flume is also one of the powder is available. So the surface area of the silica flume is 20,000 meter square per kg, and as against 230 to 300 meter square per kg that of cement. So सिमेंटच्या 230 ते 300 मीटर स्क्वेअर पर केजी against weight of that cement properties there. So the silica flume is or microsilica is an important new material. So let us see that materials in some details are. The microsilica is initially produced as an ultra fine undensified powder. So at least 85% of SiO2 content is there into the silica film. Again, mean particle size between 0.1 to 0.2 micron is there. Then minimum specific surface area is 15,000 meters square per kg, and spherical particle shape is there. So this is nothing but the silica flume, and these are the contents of the silica flume. So we talk about the at least 85% of SiO2 content is there, 85% in the silica flume. So 0.1 to 0.2 micron of the mean particle size is available, and the specific surface area is 15,000 meters square per kg. Then spherical particle shape is a shape of the silica flume. So pozonic action of the silica flume. What this is the properties of the press point. What pozonic action takes place? So this pozonic action, the microsilica is a much more reactive than the fly ash. So just a minute.